In this video, we will go through the basic operations with GRASS GIS. When you start GRASS, you will probably see something like this world map from a demo project. In my database, it's called World Let Long. However, in this course, we will be working with North Carolina dataset. If you don't have this North Carolina dataset called NCSPM08 GRASS 7, you can download it by clicking on this icon, Download Sample Location, and select Complete North Carolina Location. You can see there is a bunch of them. I'm not going to download it because I already have it. And to start working in this location, we can open this project and we can look at some of these map sets that we have there. But to start our work, we will create a new map set. So I right-click on the NCSPM08 project and click Create Map Set. And let's call this map set Assignment 1. Now you will get a message that the current location is NCSPM08 and the current map set is assignment. So this is the map set where any maps that we would create will be located. Now, the data that we have provided for this course are stored in MapSet Permanent. So if you double click on them, then you will see a complete list of raster maps stored in this map set and vector map layers. Before we start, we will set up working directory. This is a directory where we will save our outputs, such as images for our reports, or we will store their external data that we want to import. That way, we don't need to define a path to this directory when we do these operations. So to do that, we can, for example, type cd, create directory, enter, and we will get to the graphical user, to the file manager on our computer, where we can create a directory where we will store our data, our outputs. So I will create that directory, let's say GIS-582 report. And now our current working directory is in this GIS-582 report directory that I have created. And you will see over the course of this video and in next assignments how we will use this directory. So now what we would like to, as we have explained in the lecture, each project has defined the coordinate system. So we want to know what that coordinate system is, and we can find out either by running this command in the console. So it is the coordinate system with EPSG 3358, and it is state plane coordinate system with unit meters. Or we can find this under settings, map projections, display map projection, where we can run essentially the same command from graphical user interface. We can also find what is the spatial extent for our computational region. That means this defines spatial extent and a resolution of all the raster operations that we would be running. So here we have the coordinates. The resolution is 500 meters and latitude, longitude of the corners of that region. Now, this is a rather large region, and just to find out where we actually are, we can display elevation state 500 meters. And you can see that this region is set to the entire North Carolina. Here we have the to get to this region, when we zoom out, zoom in, we set our display to a data layer. We can always get to computational region by clicking on this icon. So for the next couple steps, we would like to work in a different region. We would like to work in a smaller region in Southwest Wake County, for which we have higher resolution digital elevation model. So let's now set the region to this elevation model. And again, we can either do it by running the command in the command line, or we can open a graphical user interface for this command, and it is under settings. Okay. So let's just remove this digital elevation model that covers entire North Carolina, and let's display the data layer elevation. And you have seen in the previous case that I just displayed the elevation for the entire North Carolina by double-clicking on that layer. So here we can do it as well, but let me remove it just to show you that we can also display that layer using command line. And by running the drust command, we add the elevation layer to the layer manager, and in layer manager we are managing the layers that are displayed in the display. Now, to enhance the topography that is represented by this digital elevation model, it is useful to display it through the shaded topography. And again, we can run it as a command, so you can just copy paste that command. But I will now do it through the graphical user interface by clicking on the icon Add various raster map layers. Aha, počkaj. So our shaded relief is here, and the color is here. And then we will make it a little bit brighter by setting this to 30. Okay, so now you can see that the topography is highlighted, and we can see the structure a little bit better. So if we want to get some more information about this elevation map layer, we can right-click on the elevation map layer and select metadata. And then in this panel, we will get a more complete information about the resolution of this layer, that is 10 meters, the spatial extent, number of rows and columns, and also the minimum and maximum elevation. Now we can, if we are only interested in the minimum and maximum elevation, we can use our info command with -r flag. Oh. Okay, I forgot to define the data layer. So now we got those 55 meters and 156 meters range of elevation for our data layer. Now, let's add some vector data to the image that we have in the map display. And let's do it through the command line. Again, we can double click on these layers in the data catalog. So for example, here is our streets wake, roads major. So we can just double click on this, or we can copy these commands into console and display it that way. So here we have the streets layer. Then we want to highlight the highways. So these are the major roads. And then we will display the schools to see how they are distributed. And when you want to change, for example, the color of the symbols or the symbols themselves, you can, or any other property of the displayed vector data, you just double click and let's just say select a different fill color. And we will talk about the display of the data and creating actual maps later on. So here we are just doing the very basic display of data. So now we can save this image. You can also add the legends, the vector legend, the raster legend, and the scale. And again, we will be exploring those options later on when we will have a unit on data display. So let's just save this very simple image. And now you can see that automatically we are saving this image into working directory that we have created. And let's call it Wake Schools and Streets. Okay. And again, we can do it, so we can do it by clicking on this icon, or we can do it by running the command dout file. And again, like here we are calling it my map, but you can call it something more meaningful, like I tried the schools and streets. I will keep here my map so that we can distinguish it. But what I wanted to highlight that in the assignments, wherever you have this dout file command, those are the outputs that we expect you to put into your report. So when you look at that directory, you should see that my map there as well. So let's now look at the data in 3D. So let's switch all of these layers and keep only the elevation layer. Let's make sure that we are zoomed into region. And now what we can do, you can see here is the 2D view, 2D view option, and we can switch from 2D view to 3D view. Okay. Now you can, to get the full access to the graphical user interface that controls the 3D view, we can undock it. So I just dragged it with mouse. And now I can manipulate my three-dimensional view. So I can look at the topography from south. I can increase the height of the view. And then I can also increase the resolution because currently only some of the cells are viewed, actually only each sixth cell, so it's much lower resolution. So let's just click on it. So here we got much sharper image. And another thing that we can do, we don't really have this kind of mountains here. And that's because it looks like big mountains because our Z exaggeration is set to 10. So we can lower it to, let's say, 3, increase the height by changing this number, let's say, to 7,000. And let's see, let's just look at it from here. And you can find a nice view that you would like by yourself, and then save it to the let's just make that window a little bit bigger. Okay, and then you can zoom out a little bit. Okay. So let's now switch back to two-dimensional view. And let's quit this video for now. And then in the second part, we will look at the data view and query import and export of data.